Today we are going to look at fractional exponents. So let's take a look at this first one here, and we've got an 8 to the 1/3 power. So what we're going to do is we're going to represent this as a radical. And so the way we do that is we take our 8, and that is called our radicand. The radicand is the number underneath the radical sign. So this is our radical sign, or radicand. And then we have this top number. This top number is the number in which we are squaring or cubing or bringing this radicand to a power. And so this is the power here. And the 3 represents the index. It tells us the number of roots that we're looking for. And so that's what we're looking for when we're talking about radicals. We're looking for the number of roots. So 8 is to the first power, but we're looking for 3 numbers that multiply to make this 8 to the first power. And so there's this way we can represent it, and we can also do it this way as well. We can also treat it as 3, the cubic root of 8, and then bring, once we go ahead and take that cubic root, and then we can bring it to that first power. And either way will give you the same answer at the end. I prefer this method because eventually we're going to end up with numbers other than 1 on the top of this fraction. See, all these problems that we're dealing with all have 1. In part 2, we're going to deal with ones that don't have 1 here. And it's easier to go ahead and take the roots of smaller numbers first, and then take the exponent later. So we're going to do it this way. So we're looking for 3 numbers now that multiply to make 8. Well, as we think about that, you're looking at, for instance, since this is an even number, I'm not going to try odd numbers. I'm going to try even numbers. So I'd probably start with 2's. And you see how 2 times 2 makes 4, times another 2, that makes 8. There's our answer. So that means that the cubic root of 8 is 2. Well, again, we're bringing that to the first power, but 2 to the first power just leaves us with 2. So the same sort of thing here. This 16, the base of our term here, represents our radicand. And we draw the radical sign. So the 4 represents the number of roots that we're looking for. That's the index. So we're looking for, the last problem we had 3 numbers that multiply to make 8. Here we have 4 numbers that multiply to make 16. Once we get that answer, again, I like to put the exponent on the outside, that power on the outside, because I like to take the roots of smaller numbers first, then do this exponent. And so I need now 4 numbers that multiply to make 16. Again, I would stick with even numbers. It has to be even because we've got an even radicand. So the deal is that if it's an odd number underneath, we're going to try odd numbers. Even numbers, try even numbers. So let's try these 2's again. Well, 2 2's make 4. 2 more 2's make 4. 4 and 4 make 16. So that's our answer. So the 4th root of 16 is 2. And we're raising that to the first power, which is 2. And there it is. Well, this next one is just 0, so it's kind of a tricky problem because we're looking for what 6 numbers multiply to make 0. And then we have to take that number to the first power. Well, what 6 numbers multiply to make 0? Well, 0 times 0 times 0 times 0 times 0 makes 0. 0 to the first power is still just 0. So that would be our answer. Well, 27 to the 1/3 power, same sort of thing. 27 is the number that goes underneath that radical sign. We're looking for 3 numbers that make 27, and then once we do that, we raise it to the first power. And so from this point, we're looking for 3 numbers that make 27. Now we have an odd number, so don't try evens, try odds. So I'd start with a small number like 3. 3 times 3 makes 9, times 3 makes 27, so that does work out. So the cubic root of 27 is 3. Those are the 3 numbers that multiply to make 27 that are all the same. Well, then we raise it to the first power, and it just leaves us with 3. So there is our answer. Well, the next few problems have the same sort of thing. It's just an extra operation that goes involved between the two. So we've got now 2 numbers that multiply to make 25. That we call the square root. And so 2 numbers that multiply to make 25. We raise that to that first power, and then take away the 4 numbers that multiply to make 16. And we raise that to the first power. Well, we already know that 2 numbers that multiply to make 25, well, it have to be an odd number because we have an odd number underneath the radical sign. And just so happens to be 5. 5 to the first power is just 5. We actually already did this one. 4 numbers that make 16, that would be 2. 2 to the first power is just 2. Then you just subtract those numbers and get your answer. Well, another example here, we've got 36 to the 1/2 power. Well, that's just the square root of 36. And then raise that to the first power. So again, the numerator gives us our power that we're raising it to. The denominator of the fractional exponent is the number of roots that multiply to make 36. So same sort of thing here. We need 3 numbers that multiply to make 1. So 3 numbers, the denominator is the number of roots, that multiply to make this radicand that is all raised to the first power. Well, the 2 numbers that multiply to make 36, again, try even numbers. That's 6. 6 to the first power is 6. Over here, 3 numbers that multiply to make 1. 1 times 1 times 1 makes 1. And 1 to the first power is 1. Add those numbers together, and you get 7. So one more problem to try. We've got 81 to the 1/4 power. So we're looking for 4 numbers that multiply to make 81. And then raising that to the first power. Bring down the plus sign, do the same thing here. 3 numbers that multiply to make 8. And then we're raising that again to the first power. So we can go ahead and figure out those 4 numbers that multiply to make 81. Again, since this is an odd number, always try odd numbers. So let's take a look at these 3's. 4 3's. See, 2 3's make 9. 2 3's make 9. 9 and 9 make 81. So there it is. 3. The 4 numbers that multiply to make 81 are just these 3's. So it's 3 to the first power. Plus, well, 3 numbers that multiply to make 8, again, try those even numbers. 2 is the number that makes 8. When we multiply it 3 times, 2 times 2 times 2, we did it up here. Well, 3 to the first power is just 3. 2 to the first power is just 2. Add those numbers together, and we get 5. Well, there are some of the problems that we'll end up seeing on tonight's homework. The next part will deal with fractional exponents, but we'll also have a different number other than 1 on top of the fraction.